Yes, very good afternoon. Hopefully, I'm audible to you all. Okay, thanks, Kshitij. Uh, yesterday we are doing the reinforcement learning, and previously we have done passive learning scenario, and this one is the MDP process, Markov Development Model Design Model, and in which we have done some kind of optimal policies and the utilities, and there is another example which is also linked with the reinforcement learning. Reinforcement learning, and hopefully you all are aware of that tic-tac-toe game, and where we are just putting the X and O. Now, here you can just check it out here. There are multiple moves are there, and how someone can win, and what are the possible combinations are there. So, this is again behind most of the games. There is a reinforcement learning is there, and which actually learns uh, from the uh, from the multiple practices by the user. So I will also cover this up in our upcoming slides. Let us begin with the this. There is a first move is there, and here you can just check it out here. There is axis there. So where the O has to be, where O has to be assigned, and you can just check it out here. There are multiple options are there. There is one option is there, second option is there, and the N option. And so it can mark anywhere. There is a 1, 2, and up to the N. So there are 8 options are there to put the move, and here you can expect the 8 nodes at this point. So there is a, and it is just expanding by multiple moves. This one is a step A, and this one is a B step, and this one is a C. There is a D step is there, E step is there, and hopefully someone will get the result or will win or lose uh, at a F position. So there is A is there is a B is there, C is there, D, E, F. That is a deciding factor, and at the end you will definitely win or lose. That is there is a tic tac toe game, and here how we can use the reinforcement learning in this game. And here you can just check it out. So first you have to design the table, and each move had a 0.5% of probability to win or lose. So this is not a deciding factor. In first move, in a second move, in multiple sum, there are third move is there, fourth move is there, and in a first few moves, we can't decide that who will win or lose. But yes, after some points or after taking some moves, here you can just check it out here. There is a kind of a deciding factor. This one is also a deciding factor. And for example, okay, how this can be a deciding factor. For example, if zero will be put here, then that is kind of a deciding factor to win or lose. Okay, sorry, just hold for a second. Okay, yes, there we are now. Yes, now with some, yes, this one is more related to that. And here you can just check it out here. In a first, second, or in a first few moves, we can't decide the who will win or lose. And here you can check it out in this. In a B, C, definitely we can't guess it here who will win or lose. But yes, after the th 3 moves, then we can decide out who will win or lose, and who will lead, or who will lead to the lose or win. So, so this one is basically defined as a, yes. This one is actually referred to as a greedy move. So, what is that greedy move? And here you can just check it out here. Yeah, this one is a, there is a, let us begin with that. This one, there is a first move is there. Then there is a 0.5% of probability. Means one means there is a maximum probability of winning, and zero means there is a 0% probability of uh, winning. And here in a, there is a 50-50, and zero point 0.5 means 50% of probability. And again in a second move there is a 50% of probability. Again there is in a third move definitely there is a 50% of probability. But yes, in a fourth move, then there is a possibility of a winning or lose. So in this case, we just increment the equation. There is a equation which is uh, which is defined in terms of the reinforcement learning, and here this which moves towards the, here you can say that this one is a existing state, and this one is a upcoming state. So in a upcoming state, a small positive prediction will be added on the basis of the maximum probability of the winning. So this fraction will be added to the existing equation. So and in the next move, yes, in if we go towards like this and this move is there, then we have to add the another parameters and which are adding with respect to their moves. So this is a concept of a reinforcement learning in which weights are added, or you can say it as a small fraction, positive fraction will be added, which actually lead towards the winning or lose. And here you can just check it out here. There is a no weight can be assigned here, and still there is no weight can be assigned. And again, yes, there is a little bit possibility. So if the O will be marked here, there is a at this position, then X will definitely win here. So there is a probability. So we will add one fraction, 0.1. There is a 10% of probability that it will win. Okay, just added the 10% with the 50%. So there is a 60% of possibility, but yes, definitely if O will mark here, then there is a less possibility, but it will increase the uh, probability of winning of O move or a O%. So that is all about the probabilities and who will win or lose. So here there is a very shortly they have explained one means win and zero means lose. And yes, where we have to train here, yes, we have to train an algorithm over there. So what kind of a move is there? There is a multiple moves are there, S1, S2, S3. There is a move 1, move 2, move 3, move 4, 5, 6, and there is a seventh move here. You can just check it out here. How the algorithm will work out, and or it will just compete with the human. So there is a entire concept of a reinforcement or role of a reinforcement learning in games, and can at the end we can conclude that the reinforcement learning addresses a very broad and relevant questions. How can we learn to survive in our environment? And there is a most of the reinforcement learning algorithms are based on the Markov design process, and in which the state of the world only depends on the last state of action, and which is very clear. And because this is actually depends on the this previous one, and this one is actually depends on the previous one. So there is no any concern about the this to this figure. Sorry, this node of the this node. So it is just connected with each other, but actually depends on the previous one. So that is a Markov assumption, and but still there are a lot of reinforcement learning models are there. You can just go through and check it out, and what are the different models available, different models for the reinforcement learning, and go through it, and you will learn some very real time examples, and it is very good if you will try to make the project on such kind of activities. And one more thing, there is a, very common example of a reinforcement learning is there is a line following robot. So once basically what we are doing in a line following robot, we are just mark the black line, and there is a sensor which automatically follows the black line. And on a next day, what is that is simple electronic device. So on a next day, I have trained. I have just moved the robot or a line following robot. 2 or 3 days, I have trained him for 2 to 3 days or a 1 week. Then after a 1 week, I have just removed that the black line. Then how that robot particular follows the same path. So on the basis of training, he can follow the same path. So what I want to say to you, we can just add the machine learning algorithm to the line following robot, and which they can learn from their existing training, which doesn't require the uh, training from the user. So that is one of the best example, but you can just explore more and more ideas which are related to the reinforcement learning. And there is a most of the intellectual as well as the electronics, automatic electronic device, they are generally related with the reinforcement learning. So definitely you can do some or you can explore some more applications of reinforcement learning. And with this, your second last chapter has been done. And 1 second, just I have to check it out. Hello. Okay. Okay. 1 second. Okay. Yes. Your last chapter is the evaluation matrix, and which is also an important task. Yes. This is your last chapter of machine learning. And what is the use of that evaluation matrix? Now here you can just check it out. We have done a lot of classifications, and yes, the classification, the main purpose of the classification. 1 second. Yeah. Uh, the main purpose of the qualification to evaluate the predictions and to get some results. But unfortunately, there are some kind of errors which needs to be detected and removed. So if we can't detect those errors, then we can't remove that errors, and therefore we use the evaluator metric. And here you can just check it out here. What is the importance of the evaluation metric? There is a training objective, and you can just ignore this point. I will just get into the important points. So this one is important, which is useful to quantify the gap between desired performance and the baseline. So the it is actually defining the uh, what is the gap between the actual or a predicted value. So there is an error between these 2 points, and we can improve it once we can detect it. So how we can detect it? With the help of the evaluation matrix. So we can just quantify those gaps, and we can get the desired performance and the current performance, and measure progress over the time, and how the reinforcement learning methods are going better, and how a particular robot learning more and more with respect to the time, and we just evaluate their accuracy each time and give the reward points, and useful for the lower level tasks and debugging. And so, what is the actual meaning of a metric? Metrics are generally used to uh, check the correctness of the classification. So uh, so the metrics are very useful and important for the evaluation, and we can make our algorithm more better. So uh, these are some definitions which are related to the binary classification. There are some definitions which are related to the binary classification that I will use in the upcoming slide. there is a, in which I am assuming that the X is the input and Y is the binary output. What do you mean by binary classifications? For example, if there are, for example, there is a land is there, and there are some multiple objects are there. So here you can just check it out here. There is a pentagon is there, there is a circle is there, triangle is there, and there is square is there. So I have to basically according to the process I have to classify into the multiple form. But in case of a binary classifications, I can just divide or define or classify this image in two class categories only. For example, I can convert it into the there is a square and the non-square. Yeah, these are the square, these are the squares, and this one is a non-square. The triangle is a non-square, circle is non-square, and there is a hexagon is a non-square. So I can divide into the two categories. This one is your first category, and this one is your second category. And if I'm able to divide, or I'm designing an algorithm which divides all these parameters available in this space into the different categories. For example, more than two categories, then we can say it as a multi-classification. So in this case, we are talking about the binary classification in which the binary output can be either 0 or 1. 1 is in favor and the 0 is in not in favor. For example, there is a, if I am looking for the square, then yes, which is it square or not? So that is decided by the binary output. And there are two types of models, and that I will not explain in details. And you have to ignore this point because we have already covered a lot of points according to the this KNN decision tree, logistics, SVM, and there is a new. We have not done this one. There is a linear regression is there, but we have not done neural network. That is a little bit advanced version of the classifications, but you must have to go through this point. That is a neural network. So there are multiple binary classification methods are there. So now, what kind of a class evaluation metrics are there? The first one is a score based. In a score based is like that. Here you can. They are very. These are very useful in the evaluation of a logistic regression and which one is getting the better results. And here you can just check it out. This one is a positive example, positive, and this one is a negative example. There is a negative, positive, 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 and how we can evaluate the results and how these sequence have been made. First, we have to just learn about that. For example, there are some data points are there, and we have just made the regression, and some there is a differences are there. Uh, we can just check it out here. There is a then that is very near, so we can assume it as a positive, 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 and that is we can assume it as a negative or positive. There, for example, there is here, then we have to consider it as a negative. So this one is a data point. So there are some positive and negative examples are there, and we can just calculate the prevalence, and in which the positive examples are divided with the total number of the examples. So in this case, there are, for example, the n number of examples are there. So we have to divide the positive examples with the uh, total number of the examples. So this is a formula to calculate the score-based evaluation metric. And next, we have to just do a little bit more about the what are the uh, true and false, positive, negative. And this is a part of a confusion matrix. Yes, you can just check it out here. In you can or you can correlate these definitions with this graph. So in a true positive are the relevant items that we are correctly identified as relevant. Okay, please remember this point. This is you have to go through very carefully. True positives are those which are correctly identified as a relevant because there are some relevant items are there and these are correctly identified as a relevant item. And what are the true negatives? True negatives are the irrelevant items are identified as a irrelevant items. So that is again correctly. So we can say it as a true negative. Remember that the true positive means which are correctly classified. Either is a, it is either relevant or irrelevant. So if they are correctly identified, then we have to say it as a true. And if it is relevant, then we have to say it as a positive. And if it is irrelevant, then we have to say it as a negative. So what do you understand by these two terms? There is a false positive. These are basically there is a you can expect this kind of a question in the MCQs in which you may be asked what are the type 1 errors or the type 2 errors, and here you can just check it out. The false positive. False positive are irrelevant irrelevant but incorrectly identified as a relevant. There are some irrelevant items are within a space, but they are actually recognized as a relevant space. So they are incorrectly identified. So we have to say it as a false positives. And there is what are the false negatives are the relevant items which are identified as a irrelevant. So that is referred to as a false negative. And we can just remember all these terms with the help of this table. And here you have to just check it out. For example, uh, yeah. Now here I am talking about the this. For example, we have uh, we have to just I have to make it uh, little bit in a proper form. Yeah. There are there is a in a first there, for example, in a matrix I have made a matrix and in which one second. Yeah. Yeah. We have to check it out here. There is a, for example, there are some relevant and non-relevant examples are there, and you can also remember with the help of this chart. And how you can remember this point? And first you have to identify that which one is a true and which one is a negative. And for example, if the item definitely there is a relative column and this one is a irrelevant column. You have to first divide a space into the two columns. There is first one is relevant and another column is irrelevant. So if it is for example, this one is a classified data. You can assume it as a this is a identification or this is a actual data. This is a actual. This is the actual data, and this one is a classified data. This one is a classified data. For example, this one is a relevant and this one is a irrelevant column. Or this one is a this row is belongs to the relevant and this one is a irrelevant. That is I. Okay, and if both are if the reference is a this one is a if the actual is a relevant, if there is any item which is actually a relevant and also classified as a relevant, then we have to say it as a truly positive. Okay, and there is another case, and if the data is actually or if the item is actually irrelevant and also identified as a irrelevant, then we can say it as a true negative. So this diagonal case is actually representing the true value. So what is a false? And here you can just check it out here. If the actual data is irrelevant but actually identified as a or classified as a relevant, then we have to say it as a that is a false positive. And in the last case, if it is actual data is relevant but classified as a irrelevant, then we have to say it as a false negative. So this is the interpretation of false positives and negatives, false and true positives and negatives. So I will also explain this part in depth. Just we have to go through the other parameters which are related with the matrix, and once we have done, we just go through the some examples so that you can understand the what is a confusion matrix and what are these terms. So what is a yeah, there is a we call the true positive rate. True positive rate, definitely that what we have, there is a, once you have identified these four terms, then definitely you can just remember it as a TP is a true positive and TN is a true negative. Again, FP is a false positive. There is a false, yeah, there is a FP is a false positive and FN is a false negative. So what is a true positive ratio in which we are dividing the true positive with the summation of TP. There is a true positive and the false negative. So there is a false positive rate, which is actually divided the we are dividing the false positive with the false positive, summation of the false positive and the true negative. And hopefully you are able to get this point precision, and there is a accuracy is there which is actually divided with the true positive, and this one is one of the most important, and we can also say it as an overall accuracy in which we are dividing this parameter, we are dividing summation of these two parameters which are truly identified uh, or accurately identified with all the number of the samples. So here you can just check it out here. There is a true positive, true negative, false positive, false negative. So we have covered all the four terms, but in the upper side, we have covered only the two true terms. So hopefully you are getting this point. And the last one is a there is a F measure. That is a, one of the most important parameter, and we can also say it as a F score, which combines the precision and the recall. And how we can just calculate the recall and recall with this? There is a true positive rate, and the precision is again true positive divided by the, there is a TP plus T F FP. There is a false positive, and this one is a false negative. Yes, this is only a difference between recall and precision, and we can just, with the help of these two parameters, we can calculate the F score. So there is a, yeah, okay, it's there is a single class confusion matrix. And what do you mean by the single class? That is again that is concerned with the binary class uh, confusion matrix, in which we are considering only the two class categories. Two means there is a square or non-square. Similar here, there is a, we are just considering the positive or negative. Positive means the block is actually a square, and the negative means it may be a pentagon, it may be hexagon, it may be a triangular, it may be a circle. So there is a again this is a actual. That is just, they have just changed the term. Okay, this one is actual and this one is a predicted, and we can just say it as a, that is, we have already covered this point. That is a not there is not a scale, that is referred to as a negative. And there is a two positive, oh sorry, true positive, and this one is a true negative, we have already covered, and this one is a false positive and false negative. And this example is very similar to this one, so you no need to go through uh, by this point, but yes, definitely you can understand very well with the help of this example. And here there is again, there is a case of a spam. Here we are just taking the examples. For example, we are just filtering the spam emails, and this one is a positive spam. There is actually mails which belongs to the spam folder, and there are some mails which are important to the user but not the spam. So this is a negative. In the, that is a, in the entire database, we have identified that there are actually 320. There are actually 320 uh, uh, Actually, okay. First, we have to just take the summation of these two parameters. In actual class positive spam folders, we have identified as a there is a 363. There is just a summation of the 320 and the 43. And in there is a actual negative. Actual negative spams are there. There is a 530 plus 20, which is actually referred to as a 5. Okay, we can calculate it as a 558. Hopefully, you are clear with this term. And in an actual positive, there is out of 363, the 320 are actually identified as a correct. That is, which is actually referred to as a true positive. And out of the 363, the 43 are identified as a negative. Negative is which actually are predicted as a negative class, means not spam. And in another case, there is a there is actual negative, and the actual negative was there is a 558, and out of 558, which are actually identified as a negative, the total number is there is a 538, and 20 are identified as a that is incorrect. So the gray columns are representing the correct identification, and the orange one, the orange diagonal is actually representing the incorrect data. There is a incorrectly there is a put it into the spam folder and put it into the non-spam folder. So you just have to remember that the diagonal case which are following the two positive and the two negative, there is a actually belongs to the correct data and on which our accuracy is depends upon. And the next one is again the precision is simply calculated as a that is we have to calculate the or divide the that is 320, and what is that 320, there is a 320 is there, we have to divide the 320 by that is a summation of these two parameters, that is 320 and 340. Yeah, we can simply calculate it as a this, that is 320 divided by 340, and we can say it as a we are able to get the precision of 0.9. And if it is a 1, that is a maximum precision is there. If it is a 0, then there is a minimum precision is there. And in this case, we got the 0.94 precision. And similar, there is a recall is there. That is a, which is actually related to the rows. And here just we have divided the two positives by 363, and we are getting the recall 0.880. So just hold for a second. And now, where we are now. Yeah. The next part is a multi-class confusion matrix, and that is again there is a little bit different from the binary confusion matrix. In a binary, we are considering only the two classes, that is square and non-square. And in case of a multi-class confusion classifications, we can consider the multiple class categories. For example, and we can also we can say it as a there is a that is square. We can also include the circles, and we can also include the triangles, pentagon, etc. And here we have considered there is a you can check it out here. There is a dog, cat, rabbit, and there we have considered a multiple class category. And what are actually true? The green are actually represented as a true values, and these are red are representing actually incorrect values. So we can say it as a actually there are 23 dogs are there. Uh, okay, in actual case, we have 23 plus 11, that is a 34, 34 plus that is 38. Actually, 38 dogs are there, and the cats, again, there is a 22, 22 plus 29, that is around 51, and this one is a 20, 20, 44, that is 44. Okay, actually there are 40, 38 dogs are there, and they are actually correctly identified as a dogs with the count of 23, and corrected incorrectly identified as a cat, and that is count is 11 and the 10. Sorry, 11 and 4. 4 for the rabbit. And there are 51 cats are there, but only 29 cats are correctly identified as a cat, and rest they have identified as a different classes. And actual rabbits, there are 44 rabbits are there, but they are actually identified as a correctly identified as a 24. So this is a kind of a multi-class confusion matrix, and the green is actually representing the correct one, and the red is representing the incorrect. So let us do it with some one detailed example. And okay, okay. This example is actually taken from the satellite image, and there is a satellite image is there, and in which there are some asphalt, concrete, grass, tree, and buildings are there, and that particular image is classified, and this one is actually representing the classified image. There is a classified there is a classified, and yes, here you can just check it out here. Total asphalts are there. There is 2397, and they are correctly identified as a 2385. And the concrete, there is a concrete pixels. You can assume it as a concrete pixels. Concrete pixels are correctly identified as a 332, and incorrectly identified as a 4 as a asphalt and 1 as a grass. And the grass is actually identified as a glass. There is a total, sorry, the grass is actually identified as a grass with the total number of pixels are 908. And the trees are actually correctly identified as a tree, that is a 1084, and so on. And this one is the total number of the pixel exist within that particular image. And this one is a, we can just say it as a, that is a column total. Please remember this term. There is a column total is there, and this one is a row total is there. And hopefully you are able to get this table into your mind. And now the next is you have to find out the overall accuracy. If I will tell you, just calculate me what is the overall accuracy of that particular classified image. And once you have arranged this kind of a pixel matrix, then we can very easily identify it as the overall accuracy uh, of an image. And here we can just check it out. The overall accuracy is calculated by the summing the number of correctly classified uh, and dividing by the total number of values. And instead of doing this, because we no need to divide anything, because once you have made this kind of a matrix, you can very easily uh, calculate it, this type of a terms. Okay, this one is a correctly, sorry, this one is a some incorrectly classified, and we have to just sum these terms. There is a asphalt, there is a concrete, and this we have to plus first term, second term, third term, fourth term, and the fifth term. And totally there is a 6762. Now we have to calculate the total number of pixels exist within that image. That is actually a 6808. So simply we have to divide the total number of correctly classified pixels by 6808. So then you will able to get the total number of the you will get the total accuracy or overall accuracy. And the next is there is again that is important, but I think that is a less relevant to the with your topic, but you have to just go through this point. Also, there is a error of commission. Yeah, it can also be said as a commission error or the errors of commission, which represents the fraction of values that was predicted to be in that class but not belong to that class. So, what we can understand with this line, uh, please read it carefully, and we will just go through with the practical. There is a error of commission represents the fraction of value that are predicted to be in a class but not belong to that class. So uh, here you can just check it out here. There is uh, there is a true value. Just hold for a second. And okay, now where we are. Uh, okay, hopefully this point is clear to you. That is a error of commission represents the fraction of the values that were predicted to be in a class. And for example, there is a asphalt is there, and the asphalt there is a fraction of values fraction that are predicted to be in class. These are actual value which needs to be exist within that, but not but don't belong to that class. So out of the 2394, there are some pixels are there which are not actually belongs to the that asphalt. So how many pixels are there? For example, you can assume it as a there are four which has to be predicted or classified uh, in asphalt, but they have not been classified in the asphalt category. So we have to just plus this term. There is a 4 plus 1 plus 1. There is here. There is a 4, 1 plus 4. And you have to divide with this total number of the pixels. There is a total number of the pixels which fall under the asphalt category. And after that, we are able to get the commission error. So according to the commission error exists within the asphalt, we can say it as a you have just have to multiply with the 100 and you will get the 3.8. And the next one again, you can just calculate yourself, and you can I will take another example. There is a tree. In a tree there must be a there must be 1093. There are some uh, the total pixels which are classified under the tree category, and out of the 1093 and only there is a 1084 are correctly classified, and but the 9 pixels are not correctly classified. So I have to just uh, divide incorrectly identified pixels with the total number of the pixel within the same category. So please remember this term. You have to remember it. There are some pixels which are incorrectly identified in a row. First, you have to check it out in a row, and which are incorrectly identified. Yeah, incorrectly identified, and you have to divide with the 271. Here you can just check it out here. There is a 12 and 6. There is a 2. So the error is a commission error is there is a 8.7. So the last there is a not a last one. Again, there is a next is a omission error. Omission error which represents the there is a fraction of value which belongs to the class but were predicted to be in a different class. So in a previously, the commission is actually concerned with the these rows, and but the error of omission or omission error is concerned with the columns. So in this, that is not actually a column, that is actually concerned with the true data or a reference data. And the commission error is concerned with the classified data. So simply you have to remember with this point, there is commission error, which is concerned with the classified. The predicted is actually a classified data, and these classified data is represented by the rows. And this one is a true data or a reference data, which is represented by columns. So in a mission errors, there is a incorrectly identified. You can just take it as this example. Tree. We have to calculate the mission error for the tree, and you just have to divide the incorrectly pixels. There is a 1, 8, and 6. There is a 1, 8, and 6. Divide by 1099. Then you will able to get the omission error. So hopefully you are able to understand these 2 points. There is a commission and omission, and last there is not a second last. Yeah, there is a procedure accuracy is there. Okay, how can we calculate the accuracy? That is again, the procedure accuracy is concerned with the classified data, and there is a user accuracy is also there, which is concerned with the classified data. So first we have to do it with the sorry, not procedure, that is a producer accuracy. For the producer accuracy, you have to divide the total correctly identified pixels to the total number of pixels. Sorry, 1 second. Okay, you have to, that is basically user, you have to identify, for example, sorry, yeah, you have to divide the 2385, that is asphalt, with the total number of pixels within that particular column. And the next one is a con concrete, which is actually correctly identified as a concrete, and you have to divide this term with the total number of the pixels fall within that column. And again, you have to just divide with this, and hopefully you will get yeah, there is a 1. You will get the 1, that is 100% accuracy or producer accuracy in a grass category. And similar, you have to do it with this, that is you have to divide with this, then you will able to get the 99.3% of accuracy. Yeah, the user accuracy is also there, which is concerned with the classification, and that is a predicted, that is this one, that is you have to divide this term with the this, and then you have to import, you want to calculate the user accuracy for the concrete, then you have to divide the concrete, that is a concrete which are classified correctly in a concrete category, with the total number of the pixels. There is in same category, there is 332 divided by 333, and you will get this kind of accuracy, and you can do it very easily. Hopefully you are able to get my point. That is a producer accuracy is there, that is a user accuracy is there, and the last topic which is concerned with the kappa coefficient. Yeah, this one is one of the most important parameters, and the formula to calculate the kappa is you have to it is just represented by the ratio of difference between proportion of the time of promotion of that time judges agree, and what agreement would be by chance. So in this case, you just first you have to remember this point. There is a P A minus P E divided by 1 minus P E. So you have to first remember this formula, and then now my next task is we have to identify the PA and PE. So there is a for example, there is a case, there is example for the kappa coefficient measurement, and in which there are some documents are there. There are 300 documents is there, first. Then they have also found the 70 documents, 20 documents, and the 10 documents. And in these 300 documents, the judge one say that these all 300 documents are relevant, and judge two is also saying that these 300 documents are relevant. So in our next case, the judge one is saying that these 70 are non-relevant, and the second judge is also saying that this one is also non-relevant. So they both judges are agree on these 2 points. But in another case, there is a 20 documents in which they are saying that the judge one is saying that this one is irrelevant, but the second judge is saying that this one is a non-relevant. And in the third and the last point, the judge one is saying that this one is not relevant, but he is saying that. So this is a disagreement. This one is a disagreement. So if we have to calculate the agreement, we have to PA. If we have to calculate the PA, this PA, we have to just we have to add these two values. That is the agreement value. Oh, okay, first of all, you have to calculate total number of documents. There are the 300 plus 70, 20, and there is a 400 documents are there, and you have to divide the agreement. Agreement is a that is a 300 plus 70, which is 370, and you have to divide with the 400, and you will get the PA. And now the next one is if you want to calculate the PE, you have to calculate the non-relevant. That is a probability of the non-relevancy and the probability of the relevancy. So in order to calculate the probability of the non-relevancy, you have to calculate the non-relevant results. For example, there is non-relevant, 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 non-relevant. So you have to add. There is 72 times. There is a non-relevant and non-relevant. 70 plus 70, there is a 140, and again there is a 20 is there. There is 20, 160, and then there is a 170. So 170 divided by 170 divided by 800, you will get the P probability of the non-relevancy. And if you want to calculate the probability of the relevancy, you have to add the relevancy results. 300 plus 300, there is a 600. Again, there is a 20 and 30. Yeah, 630. 630 divided by 800, you will get the result, and at last you will get the kappa. You have to put these values P and PA in the there is P and PA, P and PE in the kappa equation. And if you will get the results, if the kappa is greater than 0.8, then you will get that good agreement. And if you will get the less than, there is a here you can just less than 0.8 but greater than 0.67, you can say it as a tentative conclusion, and according to this study. And there is a so the main requirement, the kappa must be greater than 2. That is a okay. Okay, leave it this part. So this is the example, and you just go through it, and this is very linked to you. And all the parameters what we have covered in the previous, then you can just go through it. And uh, with this, your entire syllabus have been done. And now, in next two classes, we will discuss about the any if there is any doubt is there, and if you have any question, then you can please feel free to ask, or uh, you can also mark your attendance. The both links are active. Please mark your attendance. Yes, please, dear all, you can just mark your attendance. Once you have marked your attendance, please confirm me and you can leave the session.